Hello everyone, welcome to today's Knowledge webinar, What's New in Creo 8. Creo 8 helps you design better products faster, and your team will appreciate the enhancement to usability and productivity with new tools for model-based definition and additive and subtractive manufacturing. Creo 8 continues to build upon new simulation and generative design capabilities. Paul Dye, today's presenter, is a member of the Virtual Center of Excellence with PTC and specializes in the area of Creo, aided by his background in mechanical engineering, engineering design, and 3D modeling. And now, for the part that concerns Knowledge, I want to let you know that Knowledge is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, faster service. And here's the product page where you can find the new Creo 8. Check us out at knowledge.com. Also, before we start, I want to remind you that I'll be recording this session and you can watch it again on YouTube and Vimeo. Just search for Knowledge. Now I will share Paul's screen so it can guide you through the new Creo 8.
All right.
We can see your screen, Paul. Yes.
Awesome. All right. So thank you again, Barbara, for having me on. And thank you, everybody here, for hopping on, attending, and checking out what's new here with Creo 8. Definitely an awesome release. A lot of really good things we introduced, and we can start to go through that. But like Barbara mentioned earlier, if you have any questions, feel free to drop that in. If you have any questions after the fact, feel free to reach out as well. We can definitely get those answered for you. And even if there's anything that we can't answer on the call today, we can definitely look into that. But we can go ahead and get started here. So looking at Creo 8, we're really looking to do design the way it should be. And we're doing that in a number of different ways. So Creo 8 sees our investment into, first and foremost, emerging technologies that we see in Creo. Things like generative design, simulation-driven design, additive manufacturing. It also sees us provide a lot of enhancements just for the everyday engineer. Things like general productivity improvements, really enabling our users to get their job done faster and be more efficient on a day-to-day basis. We also have a lot of customers that are starting to undertake a digital transformation. They're starting to switch from 2D-centric business practices to more 3D-centric methods. And Creo 8 also sees us continuing to expand our capabilities around MBD or model-based definition. So let's go ahead and start into looking at some of the enhancements just for the everyday user, things like general productivity and usability. All right, so with Creo 8, we focused on providing easier access to commands, improving the overall usability and ease of learning by rearranging and categorizing items in the dashboard, making it easier to find and also access that information. We're also providing the ability for option panels to now be torn off and moved around, either one or multiple different option panels. You can do that. And when you tear off those option panels, the system will then remember the location of those option panels during feature redefinition. That means whenever you reposition a particular panel, the next time you need to find that feature, those option panels will be in the same location. This helps first and foremost for learnability of the system, but also for users who regularly use more advanced feature commands. It's starting to expose those feature commands for them every single time they go into that feature. So a couple of different ways it's useful. The other thing we can see here that we worked on is the display of datums, specifically the display of datum planes. What we did was introduce the idea of a shaded datum plane. And the reason we've done this is to help it better ground the location of the datum plane. Because it's shaded, you can now very clearly see where that plane intersects with the part geometry and makes it easier for the user to locate and also understand in 3D space where that plane's located. From here, when we're working with more complex models, in particular models that are built from many different surfaces, users can oftentimes struggle with understanding and also organizing the model tree and the real design intent of the model. In particular, if we weren't the person that built the model originally, right, we're getting this secondhand, it could also be very time consuming to understand how the model was constructed and start to kind of make changes into the future. While with Creo 8, we've provided a number of different tools for starting to overcome some of those different challenges, starting with the introduction of a design items folder. This is displayed at the top of the model tree, provides a way for users to categorize and start to identify the functional structure of the model and the design intent of the model, really independently of the full feature history. And within that, we provided the ability to create custom groups in that design item tree. So you can really lay out your design structure and really your design intent in a very intuitive, very easy to understand way. We also have cross-highlighting, essentially meaning if I pick geometry in the graphics area, it'll now highlight both in the model tree as well as the design item tree. And overall, it's a way to allow you to clearly understand what the overall structure of the model is. This is something that I'll go through and also show what it looks like in the context of Creo. And that's something that I'll do throughout the presentation today, is talk to some of the different points and then also give you a brief overview of what that general workflow looks like in the context of Creo. But moving forward from here, the next thing we added is a new snapshot command. And the reason we have this is because many times when you're designing, particularly surface models, as you start to build out a surface, you start by building a big slab surface, and then you do a series of operations to merge that geometry in, trim the geometry, add fillets, all the things you really do to build it out. And then the final geometry that you end up with isn't actually the original surface that you started with. It's not easy to go back and understand what the original surface that I started with was. The only way to do it previously was to roll back the model in history to see what the surface was when it was created. And what we've introduced is a new snapshot item, which allows you to pick only the surface in your model, or really any surface in the model, and say, show me the snapshot. And it will show you a graphical representation of what that surface looked like when it was created, not what it just looks like now that it's been merged or consumed. It gives you a much clearer understanding of how the model is structured and the full building blocks that were used to create it. And in addition to that, we also added the option here not only just to show that quilter body, but now to copy that original surface or body. For example, if you're building out a feature that needs to reference that original surface, but now the surface has been dramatically changed, well, you're able to go back, reference that original surface, and copy it into the model tree. No need to roll back the model, makes it a lot easier for users to reuse that information that's already in their history tree. All right, with the Creo 8 here, we've also added enhancements to our hole creation capability. We've added the ability to create multiple holes within a single hole feature. This is based upon a sketch. So the user will create a sketch on a particular plane. And if they have points that are defined in that sketch or endpoints of linear entities, or even midpoints of linear entities, a hole will be created at that location. Allows you to create many holes within one single hole feature. That's simplifying the overall process. It's speeding up regeneration time, and also reducing the size of the model tree. We also enhanced our hole standard support. We expanded our lightweight holes capability. Lightweight holes were introduced a while back within Creo, as for models that have a very large amount of holes, I'm able to then switch to a lightweight representation where it gives me a graphical location of where that hole is, but it doesn't actually build out the whole geometry. That's, again, helping to speed up regeneration, helps me to do iterations a lot faster. And now with Creo 8, we've expanded that to support all hole types, where previously it only worked with a subset of holes. Moving on here, building upon our multi-body design architecture that we introduced in Creo 7. In Creo 8, we're now introducing the notion of inseparable assemblies. And what this allows you to do is take an assembly that exists and actually embed all the parts within that assembly, or even just a subset of parts in that assembly, into the actual assembly file itself. So whenever it's saved off, whether it's saved to PDM system or saved locally, what you have is just a single assembly file. It's just one business object that you're managing, tracking, keeping control of. You still do have access to all the individual parts. You can still edit the individual parts, all the relationships and interdependencies between them. Those are all things that are still maintained between those parts in the assembly, but looking at it from a bill of material standpoint, from a business object standpoint, it's stored and captured as just one single business object. Creo 8 also sees us continue to enhance our routed systems capabilities, starting with cabling. First, we've added support for branch tapes. Branch tape is essentially an identifier to say at a particular joint or junction in my cabling, you need to wrap some tape around it. It's a graphical representation or cosmetic feature to say that tape needs to be wrapped around that particular joint. And then a stiff shrink is a slightly different feature, again, cosmetic, but because it's a stiff joint, it'll actually change the flow or the path of that cable as it goes into and comes out of that joint. And from there as well, we've expanded our ECAD support using the IDX format. So that's the format that allows us to collaborate between ECAD tools and Creo. So we can collaborate by bringing in the PCB board outline and any holes that are in that board. Those are things we've been able to do. And now with Creo 8, we've added additional support for slots as well. So now we can bring in holes, those slots, and the board outline and be able to make our changes over on the ECAD side and on the MCAD side, and really collaborate between those users by leveraging that IDX format. And then here looking at sheet metal, this is another continued area of enhancement. Here we focused on the flat wall tool, and the flat wall tool allows you to essentially pick an edge and from there define the shape of your wall that you want from that edge. Whereas before we were only able to utilize one edge of a single type. What we've done in Creo 8 though is really consolidate that and allow you to pick multiple edges within a single feature definition. And because I'm picking multiple edges, I also have control over items such as miter cuts, corner reliefs within that wall definition. And then third here, the third enhancement we see over on the right is around our curve through points capability. Here we added a geodesic option. This is a particular mathematical type of curve that's defined as a curve through 2 points that follows along a surface. But it's the shortest distance between those 2 points. So that's something that's going to have a lot of great downstream uses. Moving here into rendering, our Render Studio capability, which utilizes the Luxion engine. It's the same engine that's used over in Keyshot. In Creo 8, we expanded this to now be able to take advantage of the GPU as well. So if your system has an NVIDIA RTX graphics card, Creo is able to automatically leverage that GPU to do real-time rendering. So this significantly speeds up the rendering time, allows you to get your renders done faster. We also provided a new option called denoise, which helps to reduce the fuzziness or the graininess that you get in your image while you're interacting with it. So really helping it to converge to a final solution faster. All right, so it's great to talk about some of those things, but I do also want to show what this looks like here in the context of Creo. So we can go ahead and switch over and do that now. All right, so we can go ahead and get started here with some of the general usability updates that I went over. And we're going to be working with a few different models throughout this. First one's going to be this welded model. What I'll do is edit the welded feature. And we can see with this here, the panel menus have been updated. So now I can detach them from the dashboard, display them all simultaneously. We move all those different option panels to position as best fit for what we're doing. And now what I want to do in this case is add in another weld, change the spacing so it ends with a weld there, not a gap as it is currently. But just a quick look at what we can do there with some of those different option panels. But we can move on here to show some of the updates to the model tree. Here we can utilize our lamp model. And now new with Creo 8 are these side-by-side trees, which allows us to drag out and dock to various places on the screen. In this case, I can just put it under the layer tree of our model tree there. And now we can see the design tree that I mentioned earlier, which we use to organize bodies, quotes, materials, annotation elements, and other custom groups. And so with those custom groups, we can organize the different items independent of the regeneration sequence of the features. Now here we can reorganize them, drag various design elements based on how we want to organize the model. And users can now work with that. We can set different default custom groups as well. And once they're set, new quotes or bodies that are created will automatically be put into that default custom group. Here we have one for the groups of the part. And to get a better understanding of how these quotes were used, we can use the new command show snapshot, which allows us to see a preview of that snapshot for the quilt or body, and really helps us to investigate the history of that quilt. And then for any contributing features, the command shows a preview of that geometry at the point in time after the regeneration of that feature. So for features that contribute to multiple quilts or bodies, only the snapshot of the first quilt or body is going to be shown. And then for active bodies or quotes, the command then shows a snapshot of or preview of the current geometry, whereas for something like a consumed body or quilt, the command shows the geometry before consumption. And additionally here, multiple different previews could be visualized at the same time. And here throughout this, we can now take a look at how the design progressed, really get a full understanding of how the part got to where it is now. So we can really dig in with any of those different features, see what happened at those different steps throughout the design tree, whether it be for extends, rounds, merges like we see down here, whatever it's going to be. All right, so that's just a quick overview of some of the different updates to quilting and model trees. what we can do now is look through some of the different features that we added to Creo sketching capabilities. So here we're going to be working on our CAT model, where we're taking a closer look at that feature. You can see now that Creo 8 enables new sketch-based placement for our whole feature. Now we can go through, create multiple different holes within that one feature using a combination of sketch datum points, endpoints, midpoints from the straight lines. Makes the creation much faster, much easier. And we can also now take features that we have and reference a pattern to make some of these larger changes. So here with this chamfer, we can go ahead and add it into that full circular pattern. Very quick to do that. All right, we can go ahead and move on here to work with a little bit of sheet metal. Now again, with Creo 8, we can create multiple flat walls within a common definition. So here, this enables much faster sheet metal design, as well as reduces the number of flat wall features that we're using. You can see here that all I have to do is select the walls that I want to add a flat wall onto, and it's created as one feature. And additionally, Creo remembers the previous wall height, also supports basic miter cuts here for 3 bend corners in the flat wall tool. And the relief types include, like we can see here, closed, tangent, open, rip, and it also provides inner and outer corner detection and management as well. All right, what I'd like to do now is take a closer look into some of those cabling enhancements we made. Starting here, we can go ahead and open up our cabling model. And you can see in the model tree, we have harness 1 and harness 2. We'll start by modifying harness 1. And with that, we can go ahead and look at our new branch tape cosmetic feature, which represents electrical tape wrapped around different wires and junctions and then binds them together. And that branch tape can be wrapped around wires, can be wrapped around cables, bundles, as well as stiff shrinks as well. And stiff shrinks are the other new feature that's been added to cabling. You can see that over here in our harness 2. This is a sheath feature, which allows you to route multiple different cables and wires through it. And different from the bundle feature, the stiff shrink also does not bend and remain straight along its axis there. All right, last model we're going to take a look at here is with our socket outlet assembly. Here I have that overall assembly. And what I want to do is take one of our sub-assemblies and make it inseparable. We're going to embed all the components and store them all within that one file. We could do some advanced options with this as well, to allow us to only select particular components and embed that into the assembly. And when you embed a component within an inseparable assembly, you copy the model to that assembly file. And the original model is not affected and continues to exist within the database, but the new embedded copy is now not dependent of that original model. So if you no longer need that original model, you can erase it from the session, remove it from the database, but now all the components are embedded within that inseparable assembly. It's just a single file that contains all the different components within the assembly. Okay, so just a brief overview of some of those different usability updates. Really, again, focused on just your general everyday user, really making sure that you're doing your job in the best way possible, making it easier, making it more efficient throughout that. But we can go ahead and move on here. And now I want to take a look at our model-based definition, or MBD. And since about Creo 4, we've had a continued effort to expand our MBD capabilities within Creo. And as we see more and more teams starting to transform their business from those 2D to 3D based approaches, we're really going to keep enhancing what we're working with in this area. All right, starting with symbols, we introduced a new streamlined workflow for placing and editing symbols, provide a rich gallery of standard symbols we can work with, and now users have quick access to commonly used symbols, also providing them the ability to easily customize or categorize the symbols that exist in that gallery. Symbols also now support their semantic definition in the same way that it works for annotations and notes, meaning that you can now run a semantic query on the symbol, and it'll let you know which references are associated with that particular symbol. Along that train of thought, we also enhanced weld symbols. So weld symbols are a special type of symbol that are also now semantically aware. And the difference with the weld symbol is that the references for the weld symbol are automatically populated based on the weld feature itself. Taking a look here at the GD&T Advisor, this is a tool that we again introduced back in Creo 4. It's been introduced to guide users through the process of adding GD&T to their models, educating them on the appropriate GD&T for selected geometry, and also validating that the GD&T is correct to make sure that your model is appropriately constrained. And with Creo 8 now, we've expanded the GD&T Advisor to now support assemblies. This is probably one of the most asked for enhancements around MBD in the GD&T Advisor, and it allows users now to fully constrain their models in the context of the assembly. So we've streamlined that process of Also, adding in annotations to the model that don't currently exist. You can now just simply switch to the annotation tab, create a dimension, switch right back. It's all without having to leave the GD&T advisor. And lastly, we introduced a new interface for managing annotation mismatches, particularly if you're bringing in models which have legacy annotations associated with them. The mismatch interface will now identify those issues that come up in that conversion and also give you tools to be able to go in and address any of those issues. And looking at some general enhancements, we also improve standalone annotations in Creo 8. We did that by adding support of Creo's rule-based selection. You can do loop surfaces, seed and bound surfaces. You can do all surfaces from a particular body. And that not only speeds up the selection of all those different entities, but also means going forward that the selections are now parametric. So if there's any geometry changes, they'll regenerate and update accordingly, just as any other rule-based selection would do within Creo. All right, looking at some drawing sketching tools. We have a lot of customers that still work with a large number of legacy 2D drawings that they need to maintain, but they might not necessarily have to or even want to have an associated 3D model with it. And what we did in Creo 8 was enhance our 2D drafting capabilities in our drawings. So starting with the ability to create drawing views, this allows you to, whenever you import in a 2D drawing, you can select on all the entities for a particular view and then identify that as a drawing view. So you can do that for each of the drawing views, and then you then have the ability to define the relationships between those drawing views. So say you can go now through and say, this is my front view, the top view is a projection of my front view, things like that. And then this then builds the interdependencies between all those different views, meaning then if I scale one of them, then the other views will be able to update accordingly. And we also enhanced the interface of how you go about editing and creating 2D draft entities. This leverages a lot of the interface and the workflow that we have in our Creo layout tool. And this is now being brought over into our drafting environment. So really streamlining the overall process and allowing users to make those changes much faster. All right, so that's just a quick look there at some of our model-based definitions, some of our detailing work that we're doing. And now we can move on to some of our emergent technology, things like the generative design extension, simulation-based workflows that we work with. So we can go ahead and start to look into that area here as well. And starting with Creo Simulation Live. Back in Creo 7, actually, a lot of our development time in Creo Simulation Live was spent on introducing real-time fluid simulation, initially for transient studies, where the results refine over the course of time. We know, of course, that a lot of users also want to design for the steady state. So with Creo 8, we added the capability or the ability to perform these steady state simulations. This will actually be the default now. The user will be able to switch to a transient if they would like to, but we now have the option to work between the two. We also enhanced our probes, giving you the ability to now redefine probes, both their location on the model, as well as the type of probe that you're utilizing. And this is something that I'd like to go through now and show you, something that we can take a look at what this process really looks like within Creo. So we can go ahead and get started here, pull up our data set that we want to work with. All right, so here we have a design for a faucet. We can go ahead and get that open here. And the first thing we can see is that it's a decently complex model, a decent bit of parts, sub-assemblies within there. And if we want to get started, we'll just simply head up into our live simulation tab. Again, it's not a separate software, even different window. It's just right here within the same user interface as Creo Parametric. In this case, we're going to be working with a fluid simulation. Here we have our fluid domain set up there, as well as a few different thermal conditions for initial temperature in the system. And we can go ahead now and add in some boundary conditions for our particular use case. Here we'll start by laying out a mass flow. That'll be starting down here at our pipe coming in at the lower left-hand side. And with that, we'll give it a value, change the units if we would need to. And we can go ahead and do the same thing here at our pipe coming in on the right-hand side of the model. Here we'll have that coming in at the same rate as we did over on the other side. And once we set up any of our boundary conditions, you can always stop over in the simulation tree, make any changes at any point down the road. But now that we have our mass flow defined, I also want to simulate how the system would be working out in the real world, where you would very likely have a hot and a cold side. So here we'll have the left-hand side starting at a value of 40 degrees Fahrenheit. So that'll likely be our cold side. And that means that we'll then set up our inflow of hot water to be coming in on the right-hand side of the model. We'll go ahead and set that to a value of 120 degrees Fahrenheit. And now to finish our setup, we'll then define an outlet pressure for the system. In this case here, it'll be up at the top at the spout. Go ahead and select that surface and we'll leave it at 0 pascals. And with that, our setup is complete. Now the first study that I want to go through and show is going to be in transient mode or time dependent. And then afterwards, we'll take a look at how that compares to our steady state option. All right, we'll go ahead and click simulate. And you can see pretty much as soon as I click that, we immediately have access to the results. And on my model, we can see that the velocity of the flow is changing over the course of time. That time is then being displayed over here in the legend on the right-hand side of the screen. You can also see how the velocity values are changing over time as well. And another tool we can use during our transient studies is a live simulation probe. So these allow us to monitor how certain values are changing over the course of time on particular parts of the model. So here we can see how the velocity is changing throughout the study. You can also see a graph of those values here as well. And the simulation probes work well here with the flow analysis module, but it also works very well in structural cases, vibrations, thermal, a lot of great uses we can get out of them while we're designing. And while transient studies are very useful, a lot of our customers, like we mentioned, that work in this area are interested in the steady state. So that's what we're going to do here is switch that over here in our study settings. And normally, if you want to get these type of results back around our designs, we would send them out to the analysts, and that could take hours, days, a lot of times even weeks to even get some just basic results back. But that's not what we're doing here. Instead, we just stay right within Creo, hit simulate, and within seconds, we can check out the results that we get back from the study. So here we can see that our max values are starting to settle out. In this case, it'll be for the velocity, but we could also switch that to get info on pressure, temperature, vortices. And here for the temperature, we can see exactly how those two settle out and some of the different values that go along with the system that we have laid out there. Here we can see with any of those, we can change the render state. Here we can change that to a composite view where we're only seeing the values within a particular range here. So we can go through, see what's looking like there. And clearly just overall, a lot we can do here with our steady state results to analyze what's going on here. But at the same time, we also have a lot of great flow visualization tools that we can work with here as well. So first thing we can do is go ahead and check out a direction field. So this acts as a movable plane where we can see where the direction of the flow is moving in different areas throughout the model. And again, we could adjust that over in the X, the Y, the Z plane, or anywhere in between. We could also look at the streamlines as they move throughout the faucet here, which can be a great way to see if the model is working as intended, whether that be for an internal flow case like we have here, or also for external flow cases. We could see the particle flow throughout the faucet, and with any of these, a lot of different parameters and options we could change to get a much better understanding of our use case, see how well our model is functioning there. And just overall, fluid flow capabilities within CSL or Creo Simulation Live are very quick, very easy to use. It's really a great tool for the designer. You do not have to be a CFD expert to get some great insight into the designs. And now with Creo 8, we are able to do that in the steady state as well. All right, so just a quick look through there. Definitely some really great functionality that we can utilize there. But we can go ahead and move on here. Take a look at our Creo ANSYS simulation. This is something that we released midway through our release of Creo 7 and Creo 7.0.2, but we were still able to make some different enhancements with the release here of Creo 8. We've first exposed certain controls over in the model tree for mesh control. Any changes or refinements that you make to meshing are now going to be flagged and identified in the simulation tree. We also provide mesh diagnostics inside the process manager. That means that you'll be able to more clearly understand any issues that might occur from the meshing. And then from a licensing standpoint, we've now introduced the capability for it to automatically grab a license for Creo ANSYS simulation. So we're eliminating the need for the user to explicitly grab a license before getting started. All right, moving here into generative design, we now have first the automatic creation of our generative parts envelope. Before this, if we were building out the starting geometry, I would first specify what geometry I want to preserve as well as the geometry I want to avoid. And these are still things that we want to be able to do. But what we've now done is remove the restriction that you have to specify the starting envelope. Now the system is able to automatically go through and calculate that starting envelope based on the geometry that you want to keep. So if you still want to go through and manually do that, if you still want to manually define specific starting geometry, you could still do that, but now you don't have to if you don't want to. From here, we also now made the generative design optimization asynchronous. That basically means I can start an optimization, and while it's running, I can be working elsewhere in Creo, and it's just simply working behind the scenes. Helps me to free up the system, and now you can go through and get some more design work while those are going through and solving. We also expanded our draft handling. One of our manufacturing optimizations that you can perform with the generative design engine is a casting with a parting line or a split line where it needs a draft angle. And now with Creo 8, we're able to reconstruct that straight to CAD geometry. And finally, we introduced a new manufacturing constraint for minimum crease radius. Anywhere where you have a blending as a result of the optimization, it'll define what's the minimum radius for that blending, and helps to overall more evenly distribute stress and can really help to create a smoother resulting shape from the optimized geometry. Right, this is also something that we can go through and see what that looks like here in the context of Creo. Right, here we can go ahead and get started. Go ahead and then open up our model that we're going to use to get working. And here we have a couple different bodies laid out that we want to go through and utilize for our study. You can see those all laid out here in our bodies tab. And from here, we can go ahead and jump into the study. So you can start to utilize that preserved geometry, lay that out here at the design space for our study. All right, and essentially, whenever I go through and select that, what the system will do is automatically build out that starting envelope. And it works the same way for any excluded areas. If you select on those bodies, you can see that the envelope actually automatically updates for that change, makes it much faster, much easier for us to get our generative design studies built out. And from here, we can proceed by laying out some of the different design criteria or the considerations that we'd like the system to take into account. This includes things like limit mass, design constraints. In our case, we'd like also the part to be symmetric about the middle. And finally, we'll define the material that we're interested in utilizing. All right, with those laid out, we're good to go. GTO, or Generative Topology Optimization, makes setting up the studies very quick, very easy, and we can jump right into the optimization here. And while the study's being run, we're able to view real-time what Generative is creating, and we're able to see all the different steps that it took towards getting to the final optimized geometry. And what we're seeing here is a model that's going to be probably a lot different than how you or I would have initially thought to build it out, but it's still going to be optimized for mass, stress, displacement, things that we care about. Here, we can see once it turns green, that is going to be our optimized finalized geometry. And once that's built out, we could go through display simulation results. And like we see here, we're able to then take that geometry and reconstruct it, which Generative provides two main methods of doing. First is reconstructing to tessellated, which constructs the model as a facet feature for users to then reference in order to build out a solid model. And then the second option is reconstructing to full BREP, or boundary representation, which takes the optimized portions of the design and constructs them as a freestyle feature in Creo, which we can do to varying levels of resolution. And that's what we can see here, is Creo took everything that we laid out from the preserved geometry, the optimized geometry, and it's built it into a model that we can take forward from this point, do any optimization or analysis on going forward. And we also have the option to, at any point, go back into the study. If your model or design requirements change, you're able to go through and redefine that. And that's what I want to go through and utilize here now too, is one of our new geometric constraints that we can work from, that being the minimum crease radius that we can lay out here. So this is helping to smooth out some of the different areas throughout our model and really start to keep everything at a more consistent curvature. All right, with the new design criteria updated, we simply just keep everything else the same. We don't need to go back and redefine everything. We can just simply jump right back into our optimization. And we can monitor the progress of our study using the process manager throughout that. We're able to view, again, that reconstruction real time while the optimized geometry is being built out. And here, once the model turns green, we know that our optimization has been completed. And what we can see is geometry fairly similar to what we got from our first run, but now that we've placed a minimum crease radius on, we've smoothed out a few areas, made everything more consistent overall, and still kept under our mask limit. And again, from here, if I'm pleased with the resulting geometry, we're able to update the design, which will then recreate that geometry, along with any other features that we used from that point out. And that's really one of the best features of generative topology optimization in Creo, because it's seamlessly integrated with Creo parametric. Whenever the optimization is done, we don't have to generate a whole new part, do any data translations, none of that. We just simply update the design that we're working with and we keep moving forward. That really helps us to stay more organized, take less time throughout the process, and ultimately end up with some really great design ideas. All right. So we can go ahead and move forward here. So that's some of the things we wanted to hit on around a big portion of our emerging technology, but we also have done a lot of work here in our manufacturing solutions, both additive and subtractive. We can go ahead first and start with our additive manufacturing. And first here, really combining our design for additive and that emerging technology around things like simulation-driven design. With Creo 8, we're really taking that to the next level by introducing the idea of simulation-driven lattices. So users can now leverage simulation results from things like Creo Simulation Live as well as Creo Simulate and use as an input into our lattice creation. That means wherever we see high stress points and low stress points, the system will essentially vary the density of those lattices in those particular areas to add in more wherever you have high stress areas and start to lower it down wherever you don't need it. So it's really allowing you to optimize the design, start to spread out and get more uniform stress distribution throughout the model. And in addition to that, we also replaced the algorithm that we use for our formula-driven lattices. So things like gyroids here, for example, these will actually now leverage the same engine that we use in our generative design studies. So that same engine is going to be used to build out those formula-based lattices. We also improved our build direction optimization. This is something that we introduced back in Creo 6 as a tool to help you analyze and also optimize the orientation of your part for different printing purposes, whether that be for minimizing the number of support structures, optimizing it to put more components, or even reduce the build time. It's a really useful tool. And previously, you were able to optimize for one of those considerations, but now you can optimize against all of them simultaneously while giving a weighting or a percentage for each of those, and then it'll optimize based upon that. And we also enhance the tray assembly itself for adding in multiple components. That means that during the assembly process, as you're adding in different volumes to the tray assembly, you're now able to say how many components that you want to add in all within one step. So really starting to streamline that process a bit. All right, this is the last thing that I want to go through and show what it looks like in the context of Creo. Again, some of these variable-driven lattices that we can use from our simulation results. This is some really great technology and something that we can take a look at here. So we can go ahead and get started here. Go ahead and pull up our model that we want to utilize. All right, so we can go ahead and get started here. So what I'm going to do here is work with our lattice variability based on those FEA results. So that's what we're going to have to do is jump into our Creo Simulation Live to get some real-time structural simulation. And you can see I have a couple different parameters set up here. First thing I have is some constraints down at the bottom. And we have a moment applied here in the inner surface of the model. And that's really all about what we need to do to define the study. We do have the option to focus on either speed or accuracy when jumping into the study. But with all of that laid out, we can go ahead and click to simulate. And with that, we have our results back. And from that point here, we can go ahead and check out some of the results that we got back. First thing that I want to look at is our von Mises stress, where you can go through here, change the rendering method, any of the units that go along with that. You could also highlight on the model itself to see where those max values would be occurring, which right now it's down at the point where it's going to be mounted. We can go ahead and zoom in here to see exactly where that's located. And in our case, that's a critical area. We definitely need to do something to distribute that stress a bit better. From here, we can also take a look at how much deformation we're getting. And in our case here, it seems to be occurring at that inner surface, wherever it's going to be contacting the bar that it's going to be mounted on. So definitely something we want to move away, maybe out towards the outer surfaces there. You can also animate on that deformation to see if the deformation makes sense, depending on how we set up the study. But what I want to do now is take some of the results that we got here from our study and export them out. So here we're going to be probing out a certain amount of points that we have here in our model, taking into account things like von Mises stresses, the deformation that we're seeing. And what we want to do now is use those values to drive the variability of our lattices based on those simulation results. And this is really what we mean by simulation-driven design. We're able to incorporate our findings here in the analysis to drive the features that we want to create. And in this case, we want to take advantage of additive manufacturing to create some of that geometry. It just simply wouldn't be possible to create using other different manufacturing methods. And now we can go ahead and jump into a lattice feature. So there's a lot of great functionality here. In my case, I want to maintain the current surface. So we'll tell Creo to keep a 2mm shell there. We can then select our cell type and change the cell size in any of the directions there. And then the next step from here would be to define the cell fill, which I'm going to use a star configuration, and then go through, change a few different parameters regarding ball and beam structure. And from here, we can then bring in those different simulation results to drive the density of our lattice. And in the past, we may have tried to manually create geometry that follows along the stress paths. And to do that, we'll define our density. And now we can make direct use out of that analysis right here within our additive manufacturing features. Right, from here, we can go ahead and get a preview of what that lattice is going to look like or how it was built out. And it looks pretty good. So now we could take a minute to review the model, see what that preview looks like. And if we like what we got, go ahead and accept it and build that right into the model. And even though that's some fairly complex geometry, over the past couple of releases of Creo, we've really optimized the system to build out those features much faster. And here, we can go ahead and take a cross-section of the model to get a better view of what that's going to look like. So in any areas that there was lower stress, we'll see a lower cell density. And in areas of higher stress, we'll see that density increase. And what we can do now is jump back into Creo Simulation Live, go ahead and rerun that simulation, and we can see what type of effect our lattice had on the distribution of stress throughout the model. And again, we have immediate access to those results. We can see what type of stresses we're seeing and exactly where they're located. Right? And we can take a look through at the model. We're not having a lot of the sharp spikes anymore, especially down here at our mounting holes at the bottom. That's another thing that we can notice here as well, is that the lattices, they're not just nice to look at, right? They're fully functional 3D geometry. Works well here in our analysis. We can take what we're seeing here, keep refining the model if we'd like to, working out more stress. But from here, we can go through, check back on some other values. Definitely seems like our deformation is similar to where it was before, but now it's not located at that inner surface. So that's definitely good here. All right, what we did change throughout this though was how much material that we utilized to get here. So the lattice reduced the weight of the part, still maintained all the structural integrity. So we really made our model more efficient. And that's really all possible due to these variable density lattices. Creo took what we get from the analysis much earlier on in the study and used that to improve the design. So that's really powerful and some really awesome functionality that we get here. Okay, so that's a look through our additive side of things. We can now take a look at kind of the other side, what we have with our subtractive features here. So what we did with, actually back in Creo 5 was introduce 3-axis high-speed machining capabilities with Creo for doing roughing and finishing operations. And now with Creo 8, we've expanded that tool to now support 5-axis machining as well. So we now have 5-axis roughing, rest roughing, and we also introduced 5-axis auto deburring. So that'll analyze the part, it'll identify all the hard edges on the part, and automatically then create a tool path to go in and machine off those hard edges. And in addition to that, we've also added options into our existing 3-axis tool paths. We've added a 3+2 machining operation for roughing and rest roughing. And then from a finishing standpoint, we've added automatic conversion of 3-axis to 5-axis for finishing and rest finishing. And that'll essentially just machine the model first as a 3-axis tool path, wherever it's able to. But if there's any areas of undercuts or areas that would mean some gouging of the part, the system will automatically convert from a 3-axis toolpath to a 5-axis toolpath to be able to machine that undercut. And I do want to mention from a packaging perspective, any customer out there today that currently has 3-axis high-speed machining will get 5-axis capabilities as part of that. So the 3-axis package that we offered will then have the 5-axis added to it. All right, so that's everything that we have to cover today. hopefully it gives you a bit of a high-level look at some of the different key strategic areas that we've really made within Creo, especially here with Creo 8. A lot of great functionality, really helping us to do design the way that it should be.
Thank you, Paul. That was riveting. I'm still waiting for some questions or comment. In the meantime, I want to show everybody where they can find the new Creo 8 and noveg.com. You can always call us and discuss the right product, the right configuration or upgrade. And I also want to remind you that this webinar is being recorded and I will post it on YouTube or Vimeo later on today. And, just trust Noveg because you can talk to us. We can assist you in any way you need. And I don't see any question, Paul. I think everybody is speechless or they get exactly what they were looking for. So I want to thank everybody for joining us today and invite everybody to try Creo 8 now or, as soon as you can. Have a great rest of the day, everybody, and bye-bye till the next webinar. Bye-bye, Paul.
Thank you, everyone. See ya.